For today's lesson, we are looking once again at ratios, but we are looking at ratios as something that are different than fractions. All right, so in order to do this, let's look once again at the drink that we made the other day. We made fruit punch using 2 parts drink mix to 8 parts water. So we had 2 parts drink mix and 1, 2, 3, 4, 5, 6, 7, 8 parts water. Now, to write that as a fraction or as a ratio, we do 2 parts drink mix to 8 parts water. And we can write that in word form, 2 to 8, using a colon, 2 colon 8, or finally in fractional form. However, this is not a fraction. It is a ratio written in fractional form. What I've written here is not a fraction because a fraction shows a part of the whole. So in this case, our 2 represents our drink mix, and our 8 does not represent the whole of the liquids in the glass. Rather, our 8 represents another part of the whole. So with the ratio 2 to 8, we are comparing 2 quantities, whereas in a fraction, we show a part of a whole. And that shows how ratios and fractions are completely different. However, you can have a ratio, a relationship between 2 quantities that seems almost the same as a fraction. For example, the fraction of mix to the entirety of this liquid would be 2 over 10. And I'm getting the 10 by adding the water and the mix together. So the fraction of drink mix in this entire cup is 2 of 10. And I can reduce that fraction because both 10 and 2 have a common divisor in 2. So I can say 2 divided by 2, and you do the same thing to the denominator that you've done to the numerator and reverse. There we go. 2 divided by 2 is 1. 10 divided by 2 is 5. So our reduced fraction is 1/5. 1/5 of my whole drink is juice mix. And I can look at that same fraction as a ratio. I can say 2 parts of my entire liquid that I've made, 2 parts of them are drink mix, and 10 parts of them are the entire drink. So 2 parts drink mix to 10 parts whole drink. And then, just like I did with the fraction, I can reduce that by dividing both numbers by 2. And I'm left with 1 colon 5. 1 to 5, which can also be written like that in fractional form. And while this fraction and this fraction are almost like they're the same thing, this one right here, it is not a fraction, it is only a ratio. And that should demonstrate to you why some relationships or ratios can be very much like a fraction and some cannot. In this section, you are asked to find the ratio of one color to another color and then to write it 3 ways. In my example, I used blue to green, which is 4 to 3. In the second example, or in the second part of this question, you have to find the ratio of one color to the whole, which means for my example, I used blue to all, and there are 4 blue Smarties, so I have 4 to, and then 16 is all of the Smarties, including the blue ones. This is particularly important for part C, because these 2 questions will guide your answer to part C. Which of these 2 questions could be like a fraction, and which could not?